This is the sixth and final example for doing indefinite integrals using our substitution method. All right, sine of x over 1 plus cosine of square root of x. Oh my goodness, this looks, there's no, like, what is the composition? We don't have a quotient rule for derivatives, and even if you converted 1 plus cosine of square root x down there in the denominator, even if you moved it up with that quantity with a -1 exponent, we still wouldn't be able to get anywhere. However, here is where I would say go back to that table of antiderivatives, and it's in your book as well as being in the lecture notes. And you might find one that looks like this, 1 over x squared plus 1, that indefinite integral. So the antiderivative of that is the arctan of x. So let's go with that and see if we can do something with that. So pause and see what you can do with it. And now I'm going to show you my worked example. So here we go. I'm going to look in the denominator there because I've got a cosine of square root of x, and in my table of antiderivatives I found this 1 over x squared plus 1. So that form is kind of what I need. So I'm going to replace that cosine square root of x with u. So I'm kind of thinking of that as my inner function, even though it's not really well, if you think of cosine square root of x as a composition, then cosine of x could be considered the inner function of that. Now, so letting u be the substitute for cosine of x, now if we take the derivative of u, we get negative sine of x dx. Well, guess what? What do we have in the numerator there? We have sine of x dx. So we're just off by the sign. No problem, okay? Because all we have to do is multiply by a -1 and we get what we need. So now if we do our substitution, what does that look like? Well, I substituted the sine of x dx for my du, and it's multiplied by a -1, so I basically substituted a negative du, and I get 1 over 1 plus u squared, which is exactly the form I need. Now that negative sign, it's like having a factor of -1 there, so that's a constant. I'm just going to move it to the outside of my integral. And now I'm perfect because this looks exactly like something that has the antiderivative of the arctan, or inverse tan. So I get negative arctan of u plus c, and now I'm going to do my back substitution. And I've got it. I've got my answer. Now remember, the way you can always check your answer is take the derivative of this and see if you get your original function. So if you took the derivative of negative arctan of cosine of x, you have to remember your chain rule, would you get sine of x over 1 plus cosine squared of x? It's a good practice problem for derivatives.